Hello, Heritage Academy Geometry students, and welcome to another exciting edition of Geometry, Seeing, Doing, Understanding. Today we're going to explore lesson 3.1, which is about number operations and equality. And as always, this presentation is brought to you by Mrs. Elzagary, PowerPoint, and the Internet. So today we're going to be taking a look at some math properties that you've already seen before. You've probably used these for several years. But when we look at them today, we're going to apply them to geometry. So it's going to make you think about them in a new way. Now, before we go any further, let's establish our new ultimate objectives for Chapter 3, and then we'll talk about our intermediate objectives. So Earth and the universe, which were created by God, present remarkable evidence of geometry. And we can see everywhere that God uses lines and angles beautifully and systematically to design a multitude of living and non-living things. Lines and angles are paramount to our daily ways of life, even though we don't always think much about them, such as the tilt of the Earth on its axis or the movement of tectonic plates. And because lines and angles are created by God, understanding how they function supports our understanding of the Lord and His magnificent creation. Now, our intermediate objectives, applying specifically to lesson 3.1, are to identify and describe algebraic postulates, many of which we have learned as properties in mathematics, and to explore how algebraic postulates relate to geometric postulates. So once again, this is lesson 3.1 on pages 78 and 79. Get your books open, get your Cornell notes in front of you, and let's get going. Now let's take a look at some properties that you've probably seen and used many times in math. The first one is the reflexive property of equality. We're basically saying here that any number is equal to itself because it just is. Similarly, with the commutative property, the order in which two numbers are added doesn't really matter, and this can apply to multiplication too, where we have something like 3 plus 5 equals 5 plus 3, and we know that 8 equals 8. The distributive property is another one that you've probably seen before, where we have A times B plus C, and we can actually distribute that value of A and multiply it by B, add that to A times C. So these properties are just accepted without proof, just like we learned in the last chapter with some of our geometric postulates. These are examples of algebraic postulates. Sometimes they're also called axioms. So now let's take a look at a few complex ideas from algebra. Remember that idea called squaring the binomial, where we can take a plus b squared and say that it's the same thing as a squared plus 2ab plus b squared? You can see from my example below with numbers that I've proven this, showing 3 plus 5 squared equals 3 squared plus 2 times 3 times 5 plus 5 squared. And if you go to the trouble of solving this, keeping in mind your order of operations, you're going to find that 64 equals 64, which is actually showing the reflexive property. What about factoring the difference of two squares? So look at this, a squared minus b squared equals a plus b times a minus b. So if we put that into actual practice with numbers, we can see from my example that 5 squared minus 3 squared is the same thing as 5 plus 3 times 5 minus 3. And again, if you do the math, you're going to find that 16 equals 16. So these properties are able to be proven to be true in algebra. So they are examples of algebraic theorems. So I know what you're thinking. You're thinking, no, I thought I was done with algebra and now it's all coming back. And you're right. Algebra and geometry are kind of like long lost friends. So we need to understand algebra to understand geometry. So let's take a look at some of these ideas. The following algebraic postulates that we're going to cover are going to state that two algebraic expressions are equal to each other, and they're going to support geometric thinking, proofs, and theorems as we move forward. So these aren't going to be new, but we need to have a strong understanding of them. So the first is the reflexive property, which we've already discussed. The second is substitution, where if A equals B, then A can be substituted for B. The addition property states that if A equals B, then A plus C equals B plus C. The subtraction property, if A equals B, then A minus C equals B minus C. The multiplication property tells us that if A equals B, then A times C equals B times C. And finally, the division property states that if A equals B and C does not equal 0, then A over C equals B over C. So don't sweat it if you're feeling like these don't quite make sense, because we're going to practice them. And probably the bigger thing for you to see right now is that these are written as conditional statements. So keep that in mind as we move forward. So what we're seeing is that algebra and geometry are like long lost friends. And we have to use algebra and our understanding of it to continue our studies in geometry. And let's take a quick look at how this works. So let's use this triangle ABC, and we're going to say that angle C equals 90 degrees, and that angle B is twice as large as angle A. How large is angle A? Well, let's start with what we know, that angle A plus angle B plus angle C equals 180 degrees. And let's continue by saying that if angle C equals 90 degrees, we can substitute that 90 degrees right into that first equation and say that angle A plus angle B plus 90 degrees equals 180 degrees. Well, how do we continue solving from here using algebra? Well, if you remember back to previous classes, you know that you can subtract your 90 degrees off of both sides of the equation, which is going to give us angle A plus angle B equals 90 degrees. Now, if angle A plus angle B equals 90 degrees, and we know that angle B is twice the size of angle A, then we can say that using substitution, angle A plus twice that of angle A equals 90 degrees. Finally, we can combine these like terms and say that 3 times angle A equals 90 degrees. And when we divide that 3 off of both sides using our division property, we're going to find that angle A equals 30 degrees. Now, did you also notice while we went through this process that we were using conditional statements? If so, good. If not, rewind and watch again, because I want you to use this idea of conditional statements as we go forward as a basis for our future geometry. Now, if you're following everything in this video, you're ready to start set 1, and I'm going to get you started now. If you haven't really tracked everything that's happened, it might be wise to go back and re-watch some of the segments in this video and to take a closer look at pages 78 and 79 in your book before starting set 1 with me right now. For those of you that are ready, let's review the reflexive property, substitution property, addition and subtraction properties, and multiplication and division properties. I'm going to keep them over there on the left so that we can refer to them. Go ahead and get out a piece of paper, and we're going to start set 1 on lesson 3.1 right now. So number 1 shows us something like this. If a squared plus b squared equals c squared, then b squared equals c squared minus a squared. And we know this is true because we can use algebra to do this. So look at your then part of the statement. Look at your conclusion. What did we do to show this, to change this equation around? We subtracted a squared, didn't we? So if we subtracted a squared, that means we used the subtraction property. So I want you, as we continue on numbers 2 through 5 here, I want you to think about what's happening in the conclusion of that statement. What operation is being used? And that's going to help you determine which property you've used. So let's look at number 2. if b squared equals c squared minus a squared, and c squared minus a squared equals c plus a times c minus a, then we can also say that b squared equals c plus a times c minus a. So look at your then statement and think about what we did. Did you notice that we replaced c squared minus a squared with b squared? That means that we used substitution to figure out that problem. Number 3 looks like this. If c over d equals pi, then c equals pi times d. So take a look at your then statement. What did we do in that statement? We multiplied. So that means we used the multiplication property. Number 4 looks like this. If angle A plus angle B plus angle C equals 180 degrees, and angle C equals angle A plus angle B, then we can say that C plus C equals 180 degrees. So what did we do here exactly? Look closely. Did you see the substitution happening? Last, we can look at number 5 and say that if 2 times angle C equals 180 degrees, then angle C equals 90 degrees. So again, look at your then portion and think about how did we get from that 180 to 90 degrees? Well, we divided by 2, which means we used the division property. So if you're still feeling a little unsure about this lesson, don't worry, we're going to continue to cover it in class. But for now, I want you to relax and rest in the peaceful knowledge that God made this earth beautiful and geometric. Until next time, guys, make sure that you're taking your notes on lesson 3.1, and I will see you in class next time.